Okay. All right, gang, here we go. So page 1 of the Unit 3 test review. So what I'm going to do is I'm just going to do the first page, so that makes this the first 7 multiple choice questions, and then you're on your own for the next 7 multiple choice questions. But I will explain the first 7. All right, so number 1. If a comet is traveling at a constant speed through space, which of the following is true about the forces acting on the comet? Okay, so right now, right this second, you should see constant speed. And then you should look at your note card that says constant speed equals no net force. Constant speed equals no net force. And then so that means, okay, there's a net force. Heck no, there's not a net force. There's a net force. Heck no, there's not a net force. There's a centrifugal force? That's just ridiculous. Who came up with that? The answer is C. There is no net force on the comet. Write that down on your card. Okay, if an object is moving with constant velocity, which of the following is false? False, false, false. Okay? So the net force acting on the object is 0. Well, we just said that constant speed equals 0 net force. So that one's true, so we're going to mark it off. The object has 0 acceleration. Well, 0 acceleration means constant velocity, so that one is also not good. So if there are forces acting on the object, then the forces must be balanced. Okay? Well, that one right there. So balanced forces means no net force. Okay, so that one can't be, that's also true. That can't be the answer. So the object has a constant force being applied to it. Okay, so this is false. Okay, constant velocity means no net force. So if there's a constant force, that means that it's false. So D is the correct answer. If the engine of a car exerts a constant force on the car, how will the car move? Okay, now, if there's a force exerted, okay, we want to write this down. I'll zoom in a little bit. Constant force equals constant acceleration. Constant force equals constant acceleration. That makes sense because the force causes the acceleration. Okay? So constant velocity is not right. We're looking for constant acceleration. Move forward, but we don't know how fast. No, that's not right. The car will move with constant acceleration. That's what we're looking for, right? Constant acceleration. Remain at rest. That's just silliness. Okay, so the correct answer here is C. Let's highlight correct answers. D was the correct answer there. C was the correct answer there. Sorry, I'm drawing everywhere, guys, and I'm trying to explain this stuff to you. If a hammer hits a nail with 10 newtons of force, the nail, this is Newton's third law right here, okay? If the hammer hits the nail hits the hammer back with the same force. Okay, so right now, I see that C and D have different forces, okay? So I'm just going to mark those off because we know it's not 1 newton, it's 10 newtons. It's got to be the same force and then opposite direction. So equal and opposite. That's this right here. 10 newtons and this word opposite direction. This one's wrong because it says same direction. So A is our answer. Equal force, opposite direction. A farmer is driving at night. He hits a deer with his truck. Which of the following is true? The truck exerts a bigger force than the deer. Heck no. Newton's third law says equal forces and opposite. The deer exerts a bigger force than the truck. No, they have to be the same. The deer and the truck exert equal forces on each other. That sounds about right. Equal and opposite. We don't know which exerts more force without knowing the mass. That one just sounds out. We'll get that one out of here. Equal and opposite. Newton's third law. 125 kilogram defensive tackle sacks a 75 kilogram quarterback with a force of 1,500 newtons. So the tackle exerts 1,500 newtons on the quarterback. We want to know what is the size of the force that the quarterback exerts back on the tackle. So if the tackle exerts 1,500 newtons on the quarterback exerts 1,500 newtons back on the tackle. Equal and opposite. If you don't have some notes about equal and opposite, you need to get them written down on your card. So the answer here is 1,500. A baseball weighs 1.39 newtons. If a player hits the ball up in the air, what is the net force on the baseball while it's falling back down? Assume there's no air resistance. If it asks us to calculate net force, then we need to draw a force diagram. Hey, look at my baseball. That's a nice baseball. All right. Anytime an object is in the air, the only force acting on that object is gravity. So right now, the only force acting on the object is gravity. And I say, well, what is the force of gravity? Well, it just told me weight equals Fg. They're exactly the same. Weight equals Fg. So Fg is 1.39 newtons. And if there's no other force acting on it, because we're assuming that there's no air resistance, then that means we need exactly 1.39 newtons. So the correct answer here is B. All right, there we go. That's the first page. Now you try the second page on your own.